We're going to start taking this apart. I do want to say a couple things though. The disco was designed to get a lot of shots. That's why it has the lighter spring, the way it was designed. A lot of people don't want power, don't want a lot of power. I'm kind of greedy for that. Can't help myself. I enjoy doing it just to kind of see, just for the challenge of it. There are a lot of people, you know, and this is just my interpretation of how to get more power out of it. There are a lot of people who have worked with discos for a long time and know a lot more about it than I do. They've taught me a lot. And this is just my take on it. So we're going to go ahead and start taking it apart. I've already taken the gauge out of here. It's kind of a pain to get out, so I went ahead and took it out ahead of time. Right in here is where I've got the two tanks married together. This extra tank that I put under here to make it practical to get some shots at that power level. So I've got a screw, kind of a pass-through screw. It has a bleed hole through it that feeds from the bottom tank up to the other tank into where the gauge used to be mounted. So back that out. We'll go ahead and take the safety, cross-bolt safety here out. Okay, there's that. Go ahead and get the screw that holds the action in here. Loosen this screw up a little bit more in here. And there we go. Okay. This is pretty much a standard disco type action. Let me show you the second tube though. Second tube, it's got threaded plug at each end. I have transferred the fill fitting down to here. Gauge fits in here, down at the bottom, locks it in there. The way I've got the stock routed out, it all won't come out as one piece. Got the transfer hole up into this, into the main part of the tube here. And then there's a screw that goes through there sealed with some O-rings that marries that all together. All right, let's take a look at the hammer assembly here, because the hammer assembly is a big part of this. In this standard bolt, I'm just using that to load the pellet. And I'm using this cocking rod because you pretty much wring the bolt off to take and cock that heavy spring. So I'm going to go ahead and take the barrel off of here. I'm going to start by removing this screw. I have changed this screw out from the standard hex, the standard Phillips to a hex. Take the bolt out. All right. Then I'm going to, I ended up putting a slotted screw in here. In fact, I swapped out that, I believe it's a 448 screw for a 632. I took and tapped that out. That should get it apart right there. Okay. Back the bolt all the way out. It's interesting, the breech on a disco will handle a 25 caliber pellet right off without any modifications. I did make a new bolt with an extended probe on it. And I'll show you how that works in a minute. The barrel that I have diameter is about the same as a stock disco barrel, 0.437, but it is 25 caliber that I bought from Mike Sayers, who supplies a lot of the barrel liners for folks. I'm going to go ahead and take this out here, and there's the barrel, and there's the transfer port. It transfers the air from the valve up into the barrel. You can see this is a whole lot bigger than a stock barrel. Slip the barrel band off this end. All right. Now we'll look at the hammer assembly here. Okay, to get that out, remove this screw here. Go ahead and take the whole trigger assembly off. Just stock trigger assembly. Now the hammer will come out. Again, this is the rear velocity adjuster. This part threads into it. So like I said, you can vary the preload on the spring. I've increased the thread sizes on these. There's a little transfer pin. That little pin wouldn't take the abuse either. Okay, here's the hammer that I have. I'll get the stock hammer and we'll compare this. Okay. Now, the hammer isn't a lot larger. It's a little bit longer. It doesn't have the neck in it. And it doesn't have as big of a notch in it. What it does have, you got to think of it, this rod and the pull device I had, that's part of the hammer weight. So that all adds into the hammer weight. So I haven't increased the weight of the hammer a lot. Now, one thing that I have done in here, I have recessed the front end of this and put a drive pin in there, and that's how I achieve the extra hammer stroke. And that plays a big difference in getting the extra power, getting that extra hammer stroke. Transfer port usually has a little piece of tubing to transfer the air. I use O-rings. I go through O-rings like crazy. And these are hard O-rings, the 90 durometer O-rings. This transfer port is quite a bit larger than stock. It's drilled out. Match drilled with the barrel to transfer as much air as possible. There's a point of diminishing returns on these sizes. Anything that is after the valve, when that valve opens, the first thing it has to do is fill this empty space before it can drive the pellet. So you got to think of that. You don't want to overdo it on those sizes. And the way this is right now, if I tried to go back to low power, it'd be kind of iffy. This is the transfer right here. This is where the valve used to fit into the tank right here. And now the other tank mates with it right there. And the gauge is down here. The valve is up in this region, so the transfer of the air happens here, and so both tubes really form a single tank. All right, I've threaded out the transfer port, or the port that connects the two tanks, and this threads into a new piece that replaces this part that used to fit in here that the gauge fit into. So this is inside the tube there. The gauge threaded down in there, like so, to get the gauge outside of the stock, right there. I've modified the threads on these and the way it seals with an O-ring and a straight thread. It just works better than a tapered pipe thread or that sort of thing. Next thing we'll do is remove the valve in this port assembly here. It's difficult to get out. If you try and get it out this way, you're almost guaranteed to cut the O-rings up. So it has to come out from the front. We'll remove these three screws. These three screws, by the way, carry all of the pressure, or they have to resist all the pressure of a full tank. If you take and overpressurize this tank, you're putting all that load onto these three screws. Think about that. It's not a safe thing. Now there is a backup behind here in that the hammer assembly goes in here, and then this goes across here, the RVA, and you've got a screw here and a screw here. So if the thing did pop, it would hit that, but still it would scare the heck out of you, and it would be an ugly situation. So don't overpressurize these. All right, so I've got that. I have to take this out. Plug here in the front. Got a large screwdriver slot. Just going to use a coin here. Okay, so this comes out. Got two O-rings to seal it. O-rings passing over these threads and sealing in there, they're susceptible to damage. It's a good idea to definitely inspect them and often replace them. I see this one has some damage right here. So I'll replace it. Polyurethane O-rings hold up a lot better than the standard Buna N. Okay, so I've got that end emptied out. All right, I've got the screws out here. Now the job is to force everything out this way. Bring it out through the front. And that is a chore.